Let me share my screen and get started.
Good
Sarah?
afternoon to you all. This is this is Group 3E, and it's Sarah, Sempala, Gerard, and Amon, and we're going to be presenting our ML. Amon.
Yes.
So we are going to talk about model deployment, and uh, given the fact that all of our review papers involve deployment of the CN, we found it necessary to deploy one of our waste image classification in line with our project. And our project name is Transparent Vision Techniques for Machine Waste Sorting. We believe CCN can automate waste sorting, boosting efficiency, reducing errors, and also scaling up operations for improved waste management and a more suitable environment. Next, please. As I'm also going to talk about the MLOP tools we selected to use. And one, we decided to use TeslaFlow 2.0 as the other one wasn't compatible for us. And this is also, it's a powerful open source framework for building and training machine learning models, especially deep learning models like CCNS. In our classification project, TeslaFlow was used to define the architecture of our CCN model, which includes specifying the types of convolutionary layers, pooling layers, and automation functions, and fully connected layers responsible for making classifications. More of TeslaFlow, I can talk about image processing, where TeslaFlow provided tools for image pre-processing tasks like resizing, normalization, and data augmentation, generating variations of existing images to improve model robustness. I'm going to talk about our second MLOP tool, which is MLflow, and it's a machine learning lifecycle management platform. In this context, it is used for experiment tracking, which means that MLflow will record and store details about our CCN model, training runs such as the model parameters used during training. So next, it's trying to show the installation of our ML tool, that's like when we try to install it on our devices. So we also have another tool, which is the DVC, and which stands for Data Vision Control, which is data vision, which it actually plays a crucial role in ensuring consistency and reproducibility in machine learning projects. It also enables developers to keep track of their data set. It was really helpful. And in our context, I'm going to talk about collaboration, where DVC allowed us, like us, our team, with the data vision seamlessly. So everyone can see the history of changes and revert to previous versions if needed. We use the data version control to add our training image dataset to DVC version control. I think that's all I have for now, and I'm going to call on Gerard to take us through the highlights. Gerard? Hello.
Hello, Jared. Okay. I think you'll find us on the way. Maybe it's good technical error. So the highlights of our hands-on tasks was that we did model versioning. Basically, as I explained with MLflow, it facilitated this model versioning in a way that it helped us to keep track of the different states of our CNN model. And each model might be trained on different parameter or a different data version. But with MLflow, we are able to store these different models independently of each other. Yeah. So as you can see, we had a data set. We had our data set from, we used Cargo at first, but then for the training we used the one for Mendeley. But then we had first split it into the training set and the test set, as you can see from the snippet. And basically this model versioning here worked in a way that it helped us to maintain the mode or to keep the version of that data set for the time we're training it. Remember, it's initially one data set, but then you split it for purposes of training and testing. But then model version helps you to keep the different states of the model. Yeah. So if we had to talk about the challenges and the solutions to the problems that we faced, we'll highlight just a few of them. And one of them was that certain libraries or dependencies that we used in this, I mean the ML tools, didn't have the features that we needed for a smooth working. I'll give an example of TensorFlow. So as you can see, we use TensorFlow 2.0 because we could not use the TensorFlow of GPU. And I can say that the TensorFlow of GPU was necessary because it enables the quick running of the model, unlike uh, unlike TensorFlow of 2.0, which took really a lot of our time in order to get results when you run a cell. In this, I mean in the Jupyter notebook. So, and the solution, basically there's no solution to this since we had to use the TensorFlow of 2.0 because if we try to use the TensorFlow of GPU, it required us to download Visual Studio and which the type Visual Studio 2019, 2012, 2019, sorry, is not compatible with our machine. So we had to go with TensorFlow of 2.0. I don't know if my colleague Gerard is back to the call to take us on.
So another other challenges than we faced, another challenge of high cost of internet. So the entire process of model development require a stable internet connection. However, the internet cost is very, very high because we have to download these dependencies, we have to download some libraries and a lot. So the solution, we mobilized the resources from our friends. We had to come together such that we get enough data so that uh, we can use one stable Wi-Fi. Yeah. So another problem we have, the project requires a lot of time. So we had to sacrifice a lot of our time to do a lot of research, read a lot of papers to come up with this project. We had to even go for consultation from our mentors to help us in the implementation of the MLOps. So the solution to this, we share tasks as group members to save time. So I'm going to explain this more in the next slide. So about the previous solution, we can see it more in the impact we have here in our project. So increased collaboration and governance. With the use of GitHub, we have been able to collaborate on this project despite the fact that we stay in different locations. So this has enabled the members to send or clone the code we are working on. So this is the link to our GitHub, and this is how our GitHub project looks like. So what we basically did, yeah, this is how the GitHub project looks like. So what we basically were doing, we're different locations, we stay in different areas, but with the help of GitHub, we're able to send our work and we keep on communicating. So yeah, with the rest of our colleagues. So GitHub helped us in the cloning of work. So the other impacts of our project, we have version control. MLOps has facilitated model versioning, enabling us to roll back to a previous well-performing version if needed. This helps migrate risks associated with losing the code in case of power insurgencies. So that is which one I think you've understood. We have project complexity. MLOps has multiple tools and technologies which make it difficult to implement all in a single project in a short time. This has made it hard for us to employ certain tools like Prometheus for deployment. So MLOps has different tools, very many tools, some which doesn't work with our machines. So this has been a very big difficulty in the implementation of our work because we had to install other dependencies, we have to install other libraries to make sure that the project is actually successful. Yeah, so I'll call upon the next colleague to discuss.
So if I'm to pick it on from there, we can now look at part of the code that we used during this process. And so first, this is a Jupyter Notebook, but then before that, you have to launch a Jupyter Notebook. And first, we created a folder where we'll do everything from. And then from this folder, we then we navigated to this directory and of the folder, and from there we created an environment, as you can see. And then from that environment, we then launched our Jupyter Notebook. Yeah. So basically, this is to enable that so that you start working within an environment. So you launch the Jupyter Notebook from the directory you're working in. Yeah. So from after launching the Jupyter Notebook, then you start working on it. And then first we have to install the dependencies or the setup. And our first thing we had to do was to install TeslaFlow and MLOP. So TeslaFlow, I installed it from the command line. And basically it was, I think, pip install Tesla. Then let me trace where exactly it was done from. I think I cannot locate it, but then yeah, that's how we did it. Then we also installed the ML flow. Yeah, so once we install them, then to check if they are there, if they have been installed, you run the pip list command, and this one helps you to see the different dependencies or libraries you have. And I think I'll see there's Tesla. It should be there. Yeah, it's here. TeslaFlow 2.16.1. Yes. So basically that one's just to check the libraries you have. Then we move to you import them. Like after installing them, of course, you need to use them in this environment. So import them, TeslaFlow as TF, and then the OS. This one, I think you already know the OS. So you also need to import it. Then for this command here, we needed to, as this one is related to the storage for this project, as you may face a problem that if you do not allocate space for this model, you may end up using your entire space on the device. So here you have to specify the device and the location, the device, or where your code and entire model is going to be. So this command here is basically to call to direct the model to where it will be stored. Yes. So this is the function, and this is how we call it. Yeah. So the next step is loading the data. Yeah. Yeah, loading the data. You importing all this the NAPI. Then we know this one. We know it, and basically this is the entire function, and you run it. I don't know here. I think I've got an error, but yeah. So then we do the scaling of the data. Then we'll also do scaling. Basically here it's uh, sizing the data to the size we want it to be. Like the images here, we are dealing with images. Then we also split it to the train size and the test size. And then this is the real gist of the matter. The model, building the model, like the code for the entire model of our model and how it will be running. I will not go into the nitty-gritties because of time. Yeah, and this is the test code that we needed. Yeah. I think that's all we had for you. We'll stop there.